The Ben Heck Show is brought to you by Element 14, the electronic design community where you can connect and collaborate with top engineers from around the world. Join now at element14.com. Hello and welcome back to the Ben Heck Show. In this week's episode, we're going to continue working on the Logic Gate board game.
So you've been working with microcontrollers and trying to get them to interact with LCDs, right?
Yes, that's correct. Microchip has a library that allows you to drive an LCD glass with just a microcontroller. You don't need an external controller or extra RAM. I got JPEGs to load, but I want to use PNGs because PNGs are better for, line drawing graphics. We should also talk about gamification. Like we could make some diagrams of how we want to space out the screen, what goes on the screen, where you put the plugs, and basically figure out how the puzzles are going to work on the screen.
Okay, so I can do some work on that and design some puzzles for testing, and you can get to work on that LCD and memory.
Sounds good. Let's get started.
Amazing hacks.
Should we take it for a spin?
Inspired designs.
Imhotep's priests.
Regrettable acting.
No one seems to get it.
Each week, Element 14's The Ben Heck Show brings you innovative projects using electronics, engineering, and more.
Okay, so this is the PIC32 MZ starter kit that we were using with the LCD. The next thing I want to do is try using this as a mass storage device with a computer. So see how there's multiple USB ports on the end? So there's one here. This is if it's a device. This one is if it's a host. So a host is like your computer. Like when you plug a USB device into your computer is the host reading the device. But I want this thing to act as a device. Like this will act as like a USB thumb drive, right? So this is the programming header, and then this one is UART with a USB converter. We're hoping that we can have a single USB port on this Logic Gate board game, and that can be used for charging as well as transferring data. All right, let's look at the MPLAB Harmony. There are a good number of examples included with Harmony. The problem is it doesn't really tell you how to use them, but well, whatever, you can't have it all, I guess. Okay, so let's look for a device example. CDC, HID, okay, here we go, MSD, Mass Storage Device, Mass Storage Device Basic. Let's see what we've got. Now what we could probably do is we could actually set up an area of NVM, non-volatile memory, or the flash, that holds the program. We could set that up as a small file system, so we could access it from within our program to get files, and then the USB could also use it as a file system so the user can put files there. Although we may want to have separate file systems, so there's an area of memory that the person cannot destroy just by plugging it into their computer. I mean, getting these examples to work isn't that difficult. The real trick will be combining them all, like some sort of sound, plus the LCD, plus the USB, plus the file system. It should be able to handle it though. Okay, what do we got for drivers? Non-volatile memory, use it, okay. Memory size, 64. I wonder if that means 64K or 64 bytes. 64 bytes would be pretty useless. All right, so looks like it's using an interrupt to drive this. All right. So PIC32s, they have everything in one memory structure, and it's kind of difficult to erase the flash. It's not really like an EEPROM flash. You have to usually do a page erase. Moral of the story is you can't rewrite the flash as many times with a PIC32 as you can with some other microcontrollers, because it doesn't actually have a dedicated EEPROM flash built into it like the Atmels do. It uses its own program storage flash as that type of memory if you want to use it. However, I mean, we're talking like thousands of flashes, which seems like a lot, but if you had a device that was storing something there every day, you could actually burn through that pretty quick. That shouldn't really be a problem though. All right, so it's a USB device, which means we're plugging this into something bigger, like a computer. All right, let's see, high speed is probably enough. So there's full speed and high speed. So high speed is higher than full speed. Full speed is like the original 1.0 spec. This is also interrupt driven. Let's see what we got here. Audio, CDC, HID, MSD. Okay, we want this one. LUN 0. I wonder what LUN stands for. Logical unit number 0. Anyway, media type, non-volatile memory. We could also use SD card or an external SPI flash chip if we wanted, but we want to use the internal flash because it's already there. So I'm trying to do this with as few components as possible. I mean, ideally, this thing would just have the PIC32 microcontroller and a power regulator on it. All right, looks pretty good. Let's try one thing. Let's go back up to the non-volatile memory. Let's see if we can bump that up to, what did we say for puzzles? 3K a puzzle? Okay, so 3 times 100. You know what the heck? Let's go to 1 megabyte, 1024 bytes. Okay, let's see if we can generate the code. Okay, it compiled. I'm going to program the device. This cable is hooked up to the device port. If we wanted to read a thumb drive with this, we'd plug it into the big port. This is gonna act as a device, so I can plug it into my computer here. Oh, Windows is doing something. Hey, look at that. Sweet. Let's take a look. It's still only 30 kilobytes. Interesting. Now let's put a file there. I just had a crazy thought. I wonder if we could actually open that in a hex editor. Oh, what the heck, let's try it. Oh, apparently I can. Oh, look, hey, look, okay, so we're actually reading the disk image in hex off of the microcontroller. That's pretty cool. FAT12, interesting. Most memory sticks use FAT32, although FAT32 conks out at about 128 gigabytes, which a lot of USB sticks are pushing now. All right, yeah, see, there's our file and hello world. See how there's 2 different versions of it? See that? That's for the long character file. Well, actually, I don't know if this one has long character file name support. There isn't actually anything in those files. Let's see if we can do that. Let's change that. Hello world. Oh yeah, I made a separate entry for hello world because it exceeded the 8-character file limit. A, B, C, D, E, F, G, H. Okay, let's put something in it. Sloths are cool. Carriage return. I like them. Carriage return. Smiley face. Carriage return. Save. All right, well, the old remnants are still there. Let's see, hello world. It should, oh yeah, there's our file, see? Pretty cool. Sloths are cool. Then you're gonna have carriage return, new line. I like them, carriage return, new line, carriage return, new line. All right, let's see if it's actually non-volatile. Everything's still there. Cool. All right, well, I'm gonna play around with how to make the size of this bigger, but we do know that it can work. So we can combine that with a file system on the microcontroller. So if someone wants to add their own puzzles to the game, they can just plug it into their computer and plop in some files. Programming verified complete. Cool. All right, so the display is still working. So all of the file system stuff is handled in the background by interrupts. So our main loop, which is just, cycling these icons on screen, that's doing its own thing. Let's hook up mass storage. Oh, what's that? Is it the blinky light we love to see? Autoplay. Oh yeah, there it is. Let's see, what's 2 4-letter words? Your call. One of the biggest things that I had to do is I had to add this event handler in the app tasks. There's a bunch of different states in there. There's only 2 that we really need, and that's power detected, like, oh, something's been plugged in, and then let's activate the USB device. Or power removed, hey, let's detach the USB device. That was the main thing. Yes, let's just see if this works. I'm going to unplug it. That's the detached state. Plug it back in. The attached state, make sure that it is non-volatile. Hey, there it is. Cool. And now just from my own edification, I'm going to look. I just love looking at things with hex editors. It's just fun. I wish I could look at the world with a hex editor and see all the problems and solve them. There's the file right there. Oh, it went over 2 sectors. I wonder if it supports directories. I mean, you'd think it would. Let's see what changed. Yeah, here's something you have to think about when you move files around. It actually leaves little reminders of them. See that? So we have a folder called stuff now, but everything else has been altered. And stuff is probably going to point to folder. Yeah, there it is. See, this is actually the folder directory. Remember in the olden days of DOS where you had to type CD space ... to go up? Well, folders still have that. See, we've got the ... and the dot entry. Yeah, so that's actually a pointer that says, hey, to go above this folder, vector to this sector. So whenever you have a directory actually is a file, and then you have those 2 redirects in it, and then you have the file pointers. And since these both fit in the 8.3 format, they don't need the extension to their file descriptors because they fit in old school, 8.3 format. Cool, seems to work pretty well. I'm gonna see if I can get the size to be kind of bigger right now. It's still stuck at 30K for some reason. I'm thinking like 128 might be better. I'm gonna shoot for that. It's taking a little bit of finagling, but Harmony is helping us harmoniously merge multiple things into one program. Karen wanted us to make the screen 10 segments high, so 480 divided by 10 is 48, times 2 is 96 pixels tall per segment. So I'm drawing here an AI in pixel mode. So I'm gonna do 80 pixels wide by 96 tall. So I copy pasted those into Photoshop and created a PNG, portable network graphics with transparency. See that there? I tilted it sideways just so it looks right. I still haven't gotten the screen orientation to work correctly. In the configurator, I made one object here, see? But then I just went in and I manually duplicated it. So I have like 4 widgets here. I don't know if the widgets are the most efficient way to do this. This library is probably overkill, but we'll see if it works. So I instantiated 4 widgets, I defined them, and now I'm going to draw them. So I'm gonna send it to the screen. Here we go. Oh, look, it's already done. Cool. All right, so now the PNG is working with transparency. Now the background is just white, but if there were objects there, it, outside of the gates would be transparent. So here's what it's going to look like with the frame. So the actual size of the glass is a little bit bigger than the image. I think I'll just leave it like that, because if we try to make the opening exactly the size as the image, then you're going to miss some of it depending on how you're looking at it. But yeah, that seems to line up pretty well. See how we have the, oh wait, there's only 3 gates there. I guess I do need to actually send it. Let's add a 4th gate. So those NORs in memory, it takes up, let's see how much, 2177 bytes for that PNG, which is pretty good. I mean, you could actually get it to be less than that. You take a look at the PNG here, it's anti-aliased. So if you don't like TV shows with Jennifer Garner, then you're anti-alias. PNG graphics use something called RLE, run length encoding, as a form of compression. It's lossless compression. So what it does is like, oh, look, I'm here. There's like 80 pixels of clear. So I'm just compress that into one thing. And there's a few things here. Oh, 80 pixels of clear. Compress that. So things that are like graphics, just like solid colors or solid transparency, you can actually compress quite a bit with PNG images and you don't lose any quality because it just does a run length encoding. It's kind of like a zip file. Okay, cool. Now we have, oh, that one's in the wrong position. So let's see if we can move these around since we don't want that one to be in the wrong position. Let's go to library 384. Okay, so let's see, it was 0 plus 96, 96, 192, 288 is what that should be. And then the bottom here would be your standard score display or timer. We obviously need to do more work on the gamification and how the screen is going to be set up, but I think if we can combine the schematic editor with a graphics driver and then create kind of like a markup language that can store puzzles in as small space as possible, I think it's a pretty good place to jump off from. Hey Karen, I know you like board games. Well, actually, I assume you like board games. Check out what I made.
Ooh, cool.
Gate.
Game pieces.
Chips. Yeah, so now we can...
these represent logic gates?
Not only that, but they're to scale.
Wow.
Yep, so we can actually position them 4 high. And the NOT gate is half the size, as you see. Mm-hmm. So we can get an idea of what displays might look like and then just kind of start hashing out puzzles.
That looks like a really complex puzzle.
Probably, like Steve Wozniak could probably figure this out in his sleep.
So do you want to start with our like super simple puzzles?
Yeah, it looks like that's an AND gate, right?
Yep.
So I guess in this case, like is it gonna give you false options? Like, ooh, here's an AND, here's an OR.
I think it depends on what level you're on. You could, so for like level 1, you would have like this or something. And then you'd have to figure out which gate to go through and then back out.
Oh, so all the puzzles use those gates, but the patch cord solution could change?
Yeah, I think so.
All right. I wonder if you could also use this as a teaching tool. Like you could you could simulate gates. Like you could, another mode is that you could like push buttons and make gates appear, and then all these inputs and outputs would dynamically update. Basically, it'd be like a free play mode, like where you can just create whatever you want. I know that's not the main mode, but something to think about.
I mean, I'm not like, oh, I'm just trying to figure out how that would.
You could put the game into free play mode, and you could, if it was a touchscreen, you could actually like, ooh, I want to put that there. Like it'd be like Minecraft. You like just put the gates wherever you want, and then put real inputs into them, and to see real outputs. So like a person could.
It's the seeing part that how would they see it? Because right now there's no indicator for what's happening.
They would see it with
side.
an LED or a multimeter or something hooked up to it.
Well, that was what I was saying.
Yes.
Like there needs to be some kind of indicator. So right now, in theory, the way we have this set up, you have to have like a wire hooked up to say like this port and then out to the port that's connected to an LED to be able to see what's coming out of here. Because if you just connect to here, you don't know what it's generating at all. So you have to hook it up right.
Yeah, I just kind of picture it now as like a experimentation tool.
So.
Because remember I talked about it a couple days ago, I'm like, oh, this thing could show you, it could help you wire up gates, but instead of having to do it with like solder or test kits, you can do it in this environment, and it's all soft, so to speak. You can like...
Ben, are we making an educational game?
Yes.
And just step back from being an electrical engineer and looking at it as a tool for you, and think of it back as a teaching tool.
Okay.
Because you're getting complicated and practical, and we need to keep it simple and fun in theory. Because that's the goal of the product. Stop trying to make it for you. Trying to make it for children.
Well, they say if you want to make something good, you should make it for yourself. Because if you enjoy it, other people will enjoy it.
How difficult is this? Because we were talking about using a touchscreen. How difficult is it to allow them to
change the gates?
Push the thing and have it.
It wouldn't be that difficult, but the thing is, if it's a game, we have to limit them as well.
I'm just worried that it's going to get tedious to be like having to move 3 wires to try everything. Of like, okay, move those there, and then this here. Okay, that doesn't work. Move those there, and move this here. I mean, I guess that could be fun. Well, I don't know. To me, like I'm already like, ugh, this is annoying.
Yeah, I think in the puzzle mode, because that's what we're talking about mostly. We're just going to talk about puzzle mode, right? For now, I think puzzle mode, these should stay the same. Like you have to make it.
Could you elaborate on what you mean by puzzle mode? Is there a timer?
Like this. I don't know if there's a timer.
Well, I mean, they're all logic puzzles.
Where when you're in the mode of the game where you're presented with puzzles, and you have to
every
solve.
mode.
We could have like free fun mode, like.
Which does
okay,
what?
don't worry about that. Don't worry about that. Yeah, when we have puzzle mode, I think these should change. You should not be able to tap. Maybe there's touchscreen functionality for something else, but for this, it's like they stay the same.
Okay. So how's that fun?
That I don't know.
Because if it's not fun, no one's going to play it.
Well, Karen, I think we need to do some serious thinking about the concept of the logic gate board game.
Yeah, it seems like we don't really know exactly how the flow of the game is going to work or like what the game actually is. We're trying to figure out all the components, but we don't actually have a game yet. So it might be time to go back to square one and just go to the drawing board and figure out what happens in the game and then work our way from there.
Yeah, if you think about the Hackmanji episode, a lot of the tension came from the timer and the cool voices and the pieces moving around, but the game itself was kind of difficult, and maybe we lost sight of that. But let us know what you think out on the community. How would you change the Logic Gate board game? What do you think we should do to make it fun?
Post that on the Logic Gate board game subspace on the Element 14 community on element14.com/TBHS.
You can also go there to read about other upcoming episodes, builds, and special events. We'll see you next time. I wonder how many things I can get this microcontroller to do at once. It's gonna be like, kill me. This episode is sponsored by Suave, advanced therapy with rich hydrators. Indulge in Suave Advanced Therapy Body Lotion. I'm too bored to read the rest of that. In the mood for a great sub? Melio's Subs.